Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on the ideal gas law. So the ideal gas law is PV equals nRT, where P is pressure, V is volume, N is moles, R is the gas law constant, and T is temperature. Temperature has to be in Kelvin, so we have to make sure that we convert into Kelvin if we're not already in Kelvin, which is going to be degrees Celsius plus 273. The ideal gas law is on your formula sheet, PV equals nRT here. So when we are looking for R is going to be our gas law constant, and it is based on the unit of pressure. So if our pressure is in ATM, we use 0.0206. If pressure is in torr or millimeters of mercury, we use 62.4. And then the kPa pressure we're not actually going to be looking at today. If we are trying to do stoichiometry using the ideal gas law, we have to do both. We have to use both the mole ratio conversions and we have to use PV equals nRT. So if we are given liters, if we're starting with liters, we have to convert to moles using PV equals nRT first, and then we put in our mole ratio and do conversions. If we are finding liters, meaning that we're given mass or particles first, then we first convert into moles of what we're given and then moles of what we're trying to find, and then we use those moles to plug into PV equals nRT to solve for volume. So if you're given liters, you PivNert first. If you're finding liters, you PivNert last. And then the last application of the ideal gas law is to find either molar mass or density. So we can do that by rearranging the ideal gas law to solve for molar mass. Molar mass is equal to density times R times T divided by P, or M dirty P. Okay, so let's do some examples. So this says to calculate the moles of ammonia gas contained in a 3-liter vessel at 324 Kelvin with a pressure of 105 atm, and then it asks for the mass of the ammonia in the vessel. All right, so the first thing that we are doing is we are calculating moles. So moles are what we are looking for. So we're going to use our PV equals nRT equation. All right, so now we need to figure out what all of my values are here. So P is pressure, which is 1.05 atm. V is volume, just 3 liters. N is what I'm solving for. R is my gas law constant. So to solve for R, I need to look at the unit of pressure. So the unit of pressure that I'm given is ATM. So if I look at my chart here, I can see that for the ATM pressure unit, I use the R value that is 0.08206. And that's all of my units there. And then lastly, I need the temperature, which is going to be 324 Kelvin. All right, so now I know all my variables, so I need to make sure that all of my variables are correct. Pressure is in atmosphere, R is in atmospheres, volume is in liters, that's good, and temperature is in Kelvin, so that's good as well, so I don't need to do any more converting. So now if I look at my equation here, I have PV equals nRT, and I'm solving for N. So if I rearrange this to get N on a side by itself, N is going to be equal to PV over RT. So P is 1.05. V is 3, R is 0.08206, and T is 324. 105 times 3 divided by 0.08206 divided by 324, and I get 0.118 moles. My sig figs are going to be 3 because I have 1, 2, 3 sig figs here, 1, 2, 3 here, and 1, 2, 3 here. Right, so I have 0.118 moles. The second part of this asks for the mass of the ammonia. So here I have 0.118 moles of ammonia, NH3. So I'm going to convert to mass, so I'm going to need molar mass. So 1 mole is equal to the molar mass of ammonia. This is 14.01, and this is 1.01 for hydrogen times 3, and I get 17.04 grams. So 0.118 times 17.04 in 3 significant figures gives me 2.01 grams of ammonia. Okay, let's do a couple more. This is to determine the Celsius temperature of 82.3 grams of carbon dioxide gas contained in a 22.5 liter vessel at a pressure of 975 torr. Okay, so here we are looking for the Celsius temperature. All right, so I'm going to use PV equals nRT here. All right, so P is 975 torr. V is 22.5 liters. N is moles, and I'm not given moles, but I'm given 82.3 grams of CO2, carbon dioxide. So since I have grams, I can use a molar conversion to get to moles. So if I'm starting with grams, I'm going to put molar mass in the denominator. Molar mass of CO2 is 44.01 grams, and that is equal to 1 mole of CO2. All right, so when I do this math in 3 significant figures, I get 1.87 moles of CO2. Now I need R. R is going to be dependent upon my pressure unit. So I'm given torr. So my R value here is going to have to be the 62.4. And then temperature is what I'm solving for. Double check my units. Pressure is in torr, R is in torr, volume is in liters, N is in moles, and then T is what I'm solving for. All right, so if I'm solving for T, I need to get rid of the N and the R, so I'll divide both sides by N and R, and I'll get T is equal to PV over NR. So P is equal to 975, V is equal to 22.5, N is 1.87, and the R is 62.4. So all of this is 3 significant figures. So in 3 significant figures, I get 188 for my temperature. Temperature, when we solve in PivNert, is given to us in Kelvin. So I have a Kelvin temperature, but I'm looking for a Celsius temperature. Kelvin is equal to Celsius plus 273. So Kelvin is 188. So to get Celsius, I'm going to subtract both sides by 273. So 188 minus 273 is negative 85. So my temperature here is negative 85 degrees Celsius. Since we're subtracting, my sig figs are digits behind the decimal. I have no decimal places, so my answer also has no decimal places. So I get negative 85 degrees Celsius. Excellent. Let's do another. So here it says, what is the theoretical yield of chromium if 3.81 liters of NO at 28 degrees Celsius are reacted with an excess of Cr2O3 at a pressure of 1.46 atm? And we're given an equation. So since we are looking for theoretical yield and we're given a balanced equation, I'm going to need to do some stoichiometric conversions here. But because I'm given a volume that is not at STP, I can't just do a regular conversion. I'm going to have to convert, and I'm going to have to use PivNert. So which one do I do first? So if we take a look at what we're given here, all right, we're given 3.81 liters of NO. And since we have an excess of chromium, that means that I don't have to worry about finding the limiting reactant. And what I'm looking for here is the theoretical yield of chromium. So that's going to be grams since it doesn't specify a unit. So I'm starting with liters and I'm going to grams. Since my liters are not at STP, I first need to convert my liters of NO into moles of NO using my PivNert equation. Okay, so I'm going to PivNert first. Since I'm starting with liters, I have to PivNert first to get to moles. Once I'm in moles, I can use mole ratio to then convert. All right, so for PivNerting, I need pressure, which is 1.46 atm. I need volume, which is 3.81 liters. N is what I am looking for. R, my pressure is in atm, so the R that I use will also be in atm, 0.08206. And then temperature is 28 degrees Celsius. Temperature is in Celsius. I do need to convert that into Kelvin. So 28 plus 273 gives me 301 Kelvin. Pressure is in atm, R is in atm, volume is in liters, temperature is in Kelvin, so I'm good to go. All right, so I'm solving for N. So that means that I'm going to divide by RT to get N. So N is equal to PV over RT. P is 1.46, V is 3.81, R is 0.0826, and T is 301K. So when I do this math in 3 significant figures, I get 0.225 moles of NO. So now that I have moles of NO, I can convert from moles of NO to moles of CR using my mole ratio, and then do moles of CR into grams of CR by using the molar mass of CR, which is 52 grams. All right, so I have 0.225 moles of NO times, I'm going to do mole ratio, so I have 3NO, so I'll put 3NO in the denominator, and I'm solving for CR, which is 2, so I'll put 2 moles of CR in the numerator, and then now that I'm in moles, I can convert into grams by using the molar mass. Moles cancel with moles, moles chromium cancel with moles of chromium, and I'm left with grams of chromium, which is the unit that I want. Right, so I have 3 sig figs here, so my answer in 3 significant figures will be 7.80 grams of chromium. So if you can remember, when we're not at STP, if we're given liters, we pivnert, then convert. If we're looking for liters, then we convert, then we pivnert. Next up, we have the same situation here. We are given an equation, which means that we are probably going to need to do some stoichiometric conversions. So this says if we have 3.25 times 10 to the 22nd molecules of Cr2O3 with an excess of NO, we're given pressure and temperature, and it says how many liters of NO2 will be formed if the reaction is completed at 35 degrees Celsius. Okay, all right, so here we are given 3.25 times 10 to the 22nd molecules of Cr2O3, and we are finding liters of NO2, right? So if I'm starting with molecules, that means I'm going to use 1 mole is equal to 6.02 times 10 to the 23rd. And then for liters, I can't use 22.4 because I'm not at STP, so I'm going to have to pivnert this. All right, so before I can pivnert, I need to get to moles of NO2. So if I'm given molecules of Cr2O3, to convert those molecules and get moles of NO2, I'm going to need to first convert to moles of Cr2O3 and then to moles of NO2. So this time I convert, then I pivnert. All right, so I have 3.25 times 10 to the 22nd molecules of Cr2O3, right? And then to convert into moles, I divide by 6.02 times 10 to the 23rd molecules, and that's equal to 1 mole of Cr2O3. Now that I'm in moles of Cr2O3, I can use my mole ratio. There's no coefficient there, so this is 1 mole Cr2O3, and then I'm converting to NO2, and there's a 3 here, so this is 3 moles of NO2. All right, so molecules of Cr2O3 cancel with molecules, moles of Cr2O3 cancel with moles, and I'm left with moles of NO2. So in 3 significant figures, that's going to be 0.162 moles of NO2. All right, and so now that I have moles of NO2, now I can pivnert. So PV equals nRT. P is 1330 mmHg. V is what I am looking for. N is 0.162. R, since my pressure is in mmHg, my R is also going to be in mmHg. So that's 62.4. And then temperature is 35 degrees Celsius. Since my temperature is in Celsius, I'm going to need to add 273 to put it to Kelvin. That's 308 Kelvin. Pressure is mmHg, R is mmHg, volume is what I'm looking for, N is in moles, and temperature is in Kelvin. All right, so I'm solving for volume, which means that I need volume on a side by itself, so I'll divide by P, and I get V is equal to nRT over P. So that's N, that's R, that's T, and then I divide by P, which is 1330. All right, so I'm going to do 3 significant figures. So in 3 significant figures, my volume is 2.34 liters NO2. Okay, find volume means that we convert, then pivnert. Given volume means that we pivnert, then convert. All right, let's take a look at this next example. This says which gaseous element has a density of 2.048 grams per liter at 157.2 Celsius and 3.582 atm. Okay, so here we are looking for an element and we're given density. So the only way to find the element is to know the molar mass. So we're going to solve for molar mass, which means that here we're going to use m dirty p. So molar mass is what I'm solving for. Density is 2.048 grams per liter. R depends on my P unit. P is an ATM, so R will also be an ATM. Is 157.2 degrees Celsius. So Celsius means I have to add 273. So I get 430.3 Kelvin. And then P is 3.582 atm. So pressure is in atm, R is in atm, density is in grams per liter, and temperature is in Kelvin. So everything is great. So let's plug in now to solve for molar mass. Density is 2.048, and then R, and then T, and then divide by P. So my sig figs here are going to be 4. So when I do that for my molar mass, I get 20.18 grams per mole. All right, so I'm going to look at my periodic table and I'm going to find which element has a molar mass of 20.18 grams per mole. So here's our periodic table. We're looking for 20.18, 10, 12, 14, 16, 19, 20.18. So that means that my element is neon. Yay. All right. Let's do one more. This says what is the density of NH3 gas at negative 25 Celsius and 683 mmHg. So here we're looking for density, which means that we're going to need to use m dirty p. All right, so to use m dirty p, I need molar mass. So the molar mass of NH3, we actually found this earlier in the video, 17.04 grams per mole. D is what we are solving for. R is based on pressure, which is mmHg. mmHg means 62.4. It is negative 25 degrees Celsius. Celsius means I have to add 273. So negative 25 plus 273 is equal to 248 Kelvin. And then P is 683 mmHg. All right. Molar mass is in grams per mole, temperature is in Kelvin, R is in mmHg, pressure is in mmHg, so everything agrees. All right, so if I'm solving here for density, that means I'm going to need to multiply by P over RT, multiply by P over RT. So density is going to be mmP over RT. Molar mass is 17.04. We have pressure, divide by R, and divide by temperature. All right, so our sig figs here are going to be 3. So in 3 significant figures, my density is 0.752 grams per liter. So this is how we use the ideal gas law, either PV equals nRT or molar mass is equal to dRT over P. Another episode of Chemistry with Wikipedia, tutorial edition. I hope you learned something, and until next time, keep on chemin'.